In this problem, we're going to find the intercepts for the graph of an equation and then test the equation for symmetry. We want to list the intercepts and test for symmetry the equation x squared plus y equals 9. The two types of intercepts that we'll look for will be the x-intercepts and y-intercepts. To find x-intercepts, we'll set y equal to 0 and solve for x. To find y-intercepts, we'll set x equal to 0 and solve for y. To find the x-intercepts, we'll go ahead and put in y equal to 0 in our equation. We'll have x squared plus 0 equals 9, where x squared is equal to 9. Solving for x, we'll get x is equal to plus or minus 3. So the x-intercepts are plus or minus 3. For the y-intercept, we'll let x equal 0 in our equation. We'll have 0 squared plus y equals 9, or just y equals 9. So we have one y-intercept with y equal to 9. We can list these intercepts: 3, 0, negative 3, 0, and 0, 9. For symmetry, we have three types of symmetry. We're going to test our equation x squared plus y equals 9 for symmetry with respect to the x-axis, the y-axis, and the origin. To test for x-axis symmetry, we'll change y to negative y and see if we get an equivalent equation. To check for y-axis symmetry, we'll change x to negative x and see if we get an equivalent equation. And to test symmetry with respect to the origin, we'll change y to negative y and x to negative x and see if we get an equivalent equation. So for x-axis symmetry, we'll have x squared minus y equals 9. If we compare this equation to our original equation, we can see that these are not the same equation. So we say that those are different. And so the graph of the equation does not have x-axis symmetry. For y-axis symmetry, we're going to change x to negative x. So we'll have negative x quantity squared plus y is equal to 9. So give us x squared plus y equals 9. And if we compare this equation to our original equation, see that those are the same. And so the graph of this equation does have y-axis symmetry. Go ahead and check origin symmetry. We'll change both y to negative y and x to negative x. So we'll have negative x quantity squared minus y equals 9, or x squared minus y is equal to 9. Again, comparing to our original equation, we'll see that this is different. So the graph of the equation does not have origin symmetry. So for our three symmetries, the graph of this equation will only have y-axis symmetry. Now, after we had checked our x-axis and y-axis and saw that we did not have x-axis symmetry, but we did have y-axis symmetry, it really wasn't necessary to check for origin symmetry because the graph of an equation cannot have exactly two of the three symmetries. It can have one or none, or actually all three, but it'll never be able to have two. And so the fact that we already knew we did not have x-axis symmetry, we could say right away that we would not have origin symmetry once we found our y-axis symmetry. So we only have y-axis symmetry in this case.